Hey class, this is the worked out notes and some practice problems where we try to go through and solve by factoring, so some quadratics with factoring, and also solving those quadratics using the quadratic formula. So make sure you are all set to go. You've got your notes all handy. You need to pause, take a break, use the restroom, go for it, rewind, all that fun jazz, and let's get rolling. To start off with, we're going to solve by factoring. We're going to talk about factoring a ton this school year. So lots and lots of things to factor with. The strategy that we go through, at least for these particular problems, looks like this. First step is make sure you set your equation equal to 0. If it's not already set equal to 0, you want to make sure it's set equal to 0, and there's a key reason for that. Step number 2, if there's a GCF, make sure you factor that out. I know we did a couple of problems like that scattered throughout the year so far, but if you see a greatest common factor, you remove that first. Again, numbers are easier if they're smaller rather than bigger. Step number 3, determine, are you dealing with the A value being 1 or bigger than 1? All right, and that's going to deal with a couple things. If the A value is 1, it's what I call a fast factor. It's going to go by quickly. You can play the X game, and I'll show you what that means, and you solve it. However, if A is greater than 1, that's a long factor. All right, you're still going to play the X game, but now you're going to factor it by grouping in order to solve it, and we'll do an example with that as well. So here we go. I've got 3 little examples to start off with. If you notice, all 3 of them are already set equal to 0, so that's nice. Step 1 is all done. Step number 2, do you see a greatest common factor between x squared, 7x, and 10? I don't either. Okay, so no GCF, that's okay. Step number 3, is A 1 or is A bigger than 1? When I talk about A being 1, whatever's attached to this x squared, that is your A number. So right there, it's a 1x squared. So in this case, you got A is equal to 1. This is a fast factor. Okay, so if it's a fast factor, all we got to do is take a look at this 10, and we're going to play the X game. And the way we play the X game is we draw a little X right here, and we put the 10 up at the tippy top, and the 7 down here at the bottom. And you think, what's going to multiply to be 10, but add up to be 7? Multiplies to 10 but adds up to be 7, that would be a 2 and a 5. It doesn't matter which one's first and which one's second, but you got to put those 2 numbers on either side of the X. And 2 and the 5, those are your factors. So because this is a fast factor, it will factor pretty quickly to be the quantity x plus 2 times the quantity x plus 5, and it still equals 0. All right. So the cool thing about this, because it's set equal to 0, the 0 factor property, all right, means you can multiply any 2 values together and you get out 0. One of those 2 has to be 0. So we can set each part equal to 0. X plus 2 equals 0, and x plus 5 equals 0. And then we go through and we solve. Subtract 2, x has to equal negative 2. Subtract 5, x has to equal a negative 5. All right, okay, so that's factoring. That's the fast factor idea. Let's look at the middle one. I got a 3x squared, a negative 12x, and a positive 9 equals 0. Look for a GCF first. I see a GCF. They're all divisible by 3, so I'll take that out first. So I've got 3 times, in parentheses, x squared. A negative 12x divided by 3 is going to be a negative 4x. And then a positive 9 divided by 3 is a positive 9, still equals 0. And the cool thing is, now that I've factored it with a GCF, these numbers got a little bit smaller. So this in the parentheses is what I want to try to work with. My A value that's directly attached to this x squared is now looking like a 1. Great. Okay, so I'm going to use my fast factor strategy, and at the tippy top I put this last number right here, 3. In the very bottom I'm going to put this negative 4. So I'm thinking, what multiplies to 3 but adds up to negative 4? Okay, well, multiplies to 3 but adds up to be a negative 4. I'm going to have 2 negatives, so that's going to be a negative 3 and a negative 1. It doesn't matter which one's first, which one's second. So I'll say in the parentheses I've got an x minus a 3. Another parenthesis, I've got x minus 1. Your GCF was a 3. That just kind of carries straight down, and the whole thing still equals 0. All right. So I'm going to use my factors and set them all equal to 0. This first one says 3 equals 0. That doesn't make sense. 3 does not equal 0, so that one's not going to work. Next one says x minus 3 equals 0. So I can add the 3 over, and x is equal to positive 3. And this last one, x minus 1 is equal to 0, so I can add the 1 over, and I got x is equal to positive 1. So this right here, that's nothing right there, but I've got my two answers, x equals 3 and x equals 1. All right, so that was factoring with a GCF as well as a fast factor. Let's look at this last one. I've got a 2x squared plus a 5x plus a 3 still equals 0. That's great. GCF 2, 5, 3. I don't see any GCF. Bummer. All right. So I'm going to look at the a value. This a value is a 2. Okay, this is a long factor at this point. So in order to do a long factor, this is the idea, the strategy that we've called sometimes build the bridge. And you take the first number, the a value, and the last number, the c number, and multiply them together. 2 times 3, positive 2 times positive 3 is a 6. That is your x game number. That's your bridge number. So I'm going to put 6 at the tippy top. Underneath is still this b guy is at 5. And I still got to figure out what multiplies to 6 but adds up to be a 5. Okay, so multiplies to 6 but adds up to be a 5. That's got to be a positive 2 and a positive 3. Great. Now if this was before, I would just say one answer is x plus 2, the other answer is x plus 3. However, it's not quite as easy as that because this is the longer method. So what I do is I keep this first guy right here, 2x squared, the same. I keep this last guy right here, plus 3, the same. And then I take this 5x and I split it up into two values, two terms. The two terms are those two parts to the x game. So this is 2 and a 3, so this is going to be plus 2x plus 3x. So you can see if I were to combine them, I do get back to 5x. But the whole point of this is because now this is structured in a way that can be factored, and we factor this by grouping. So we have 4 terms, so we put the first 2 in a group, and we put the second 2 in a group. And you look for little mini GCFs. The little mini GCF in this first group is 2 and x. You divide that out, and you're left over with x plus 1. The GCF of the second mini group right there is a 3, so I can factor out a positive 3, and I'm left over with x plus 1. The whole thing still equals 0. You're like, okay, well now what I do? I see that these guys match. That's important. If it doesn't match, we made a mistake. So they match right there, so I did something right. The match is one group altogether, x plus 1. The coefficients, the 2x and the 3, is another group, 2x plus 3, and it still equals a 0. Okay, all right. So then from here I could use that zero factor property, and I can say this first one, x plus 1 equals 0, so x has to equal negative 1. And the second one, 2x plus 3 has to equal 0, so I'd subtract the 3 and then divide by the 2, so 2x is equal to negative 3, divide the 2, x has to equal negative 3 over 2. So I've got two answers. That one's a little bit longer. Those are the long factors. Unfortunately, they happen sometimes, so just be aware. Always nice to look for a GCF first, so hopefully that gets out of there. If not, you got to do the long method to factor this. All right, and the last little concept here is solving with the quadratic formula. If you have a general standard form of quadratic, ax squared plus bx plus c equals 0, you can say, all right from the end, the quadratic formula looks like this. We'll sing it. Hopefully you've got it memorized from previous courses, but there it is. This is something that you have to know inside and outside. You have to have that memorized somehow. That's the quadratic formula. And what we do here, step number 1, we set the equation equal to 0. If it's not already set equal to 0, you got to set it equal to 0. Step number 2, find your a, b, and c value. Step number 3, use your quadratic formula. And then step number 4, don't do too much at once. Don't try to handle all this at the same time, because there's a lot of things going on, you might make a mistake. All right, let's try some examples here. It's set equal to 0. That's great. Our a value is the number in front of the x squared, is coefficient there, that's 2. Our b number is in front of the x. Well, if there's no number there, it's a 1. And then our c number is the constant, that's a negative 7. So I'm going to substitute into this quadratic formula. So I'm going to say x is equal to the opposite of b. So that's going to be a negative 1 plus or minus the square root of b squared. So I'm going to put that b in parentheses and square it, minus 4 times a times c, and this is all divided by 2 times a. So that was just a substitution. From here, what we want to do is try not to do too much at once. All right, so negative 1, and it's just kind of hanging out right now for now. Plus or minus is still that. Square root still square root. Now this is what we can calculate. 1 squared. 1 times itself is 1. 4 times 2 times 7, and it's a negative and a negative, so I know it's going to become a positive. All right, well, 4 times 2, I can calculate that to be an 8, and then the 8 times the 7, I can calculate that to be a 56. Negative times negative is positive, so it's plus 56. All right, all divided by 2 times 2, well, that's always going to be a 4. All right, let's clean this up a little bit. A negative 1's a negative 1, plus or minus is still plus or minus. 1 plus 56 is 57, and it's all divided by 4. And that's about as far as I can go. I can't simplify 57. There's no fractions that'll simplify, so I'll leave it like that. There's plenty of other ways I can write this answer, but that one is probably the most straightforward one to help you out. All right, let's try one more here. Set equal to 0, that's great. So I'm going to say my A value is a 3, my B value is a negative 12, and my C value is a 5. So I'll say x is equal to the opposite of b. The opposite of negative 12 is going to be positive 12. Plus or minus the square root of b squared, negative 12 squared. So notice this, negative times negative squared, that's going to become a positive. All right, so I got b squared minus 4 times a times c, and that's all over 2 times a, 2 times 3. All right, now we just go through and try to solve it. Don't do too much at once. 12 is 12. Plus or minus is plus or minus. Square root negative 12 squared is a positive 144. A 4 times a 3 times a 5, and it's a negative times a positive, so it's going to end up being a negative right there. 4 times 3, that's a 12, and a 12 times a 5, that's going to give you a 60. All divided by 2 times 3, oh, that's a 6. All right, let's see what else we can do here. X is equal to a 12 plus or minus the square root. And then I got to figure out, well, what is 144 minus a 60? Well, 144 minus a 60 is an 84, and that's all divided by 6. All right, and get a little bit closer here. Well, square root of 84, what builds to be 84? Are there any perfect squares inside of 84? And hopefully you realize that's 4 times 21, simplifying those radicals. The square root of 4 is 2, and the square root of 21, that doesn't simplify. So I could say one more time, x is equal to 12, that's not going to change, plus or minus 2 root 21 all over 6. Okay, I think I see where you're going with this one, Mr. Wagner. Yeah, so look what we have here. I've got 12, I've got 2, I've got 6. All three of these numbers are divisible by the same thing. They're all three divisible by 2. So what we could do is we could shrink them down a little bit. We can divide them all through by 2. 12 divided by 2 is a 6. 2 divided by 2 is a 1, so I'm not going to write if it's a 1. And 6 divided by 2 is a 3. So that's one way to simplify this. There's other ways to write that answer, but again, that way works just fine. So there you have it. We got the quadratic formula, and we got some factoring strategies. Again, if you need to rewatch anything, that's fine. If you've got any questions, make sure you jot them down, ask them in class, and we'll keep practicing this. Have a great day. We'll see you next time. Bye-bye.